Implications of Internet of Things, augmented virtual reality, and big data. We are Group M12, and I'm Daisy Cove.
I'm Stephen Kennedy.
And I'm Devin Kelly. Introduction. Manufacturing has changed significantly with the addition of new technology. This allows for faster production rates and higher part accuracy and precision. Three technologies that we looked at and are currently being used are Internet of Things, augmented virtual reality, big data.
Internet of Things is a system of internet-connected gadgets that can communicate and exchange data with the use of embedded sensors. Internet of Things applications include artificial intelligence, smart cities, smart cars, personal assistants like Siri, and smart homes. Jarvis Smart Home by Mark Zuckerberg is connected to the thermostat, doors, front gate, cameras, kitchen toaster. It uses language processing, speech and face recognition, and it communicates to mark the weather and time of the day, prepares toasted bread for breakfast, and it receives input from the front camera, uses face recognition, and lets visitors in and informs Mark on the visitor's arrival. The problems we are currently facing with the Internet of Things are safety and security. Hackers are able to access a moving smart car and take full control of it without the consent of the driver. And this is not safe for the drivers that are in the car. The idea of hackers or manufacturers accessing information from the house is not safe and will make potential buyers reluctant to buy the products on the market. 8.7 billion devices were connected to the internet by 2012, and it is believed that 50 billion devices are going to be connected by 2020. Although there are still debates about it, artificial intelligence is going to be really popular in our day-to-day lives. All these things are going to improve the way of living, and smart cities are going to control population and traffic. There is going to be increase in production and demand as the demand increases. The way of life is going to be improved. There is going to be high dependence on computers in the industry and homes. The devices connected to the internet, as more devices are connected to the internet, it means that there's going to be more security improvements that need to be done.
Augmented and virtual reality is another way manufacturing and design is being revolutionized. AVR is the term used to describe a 3D computer-generated environment which can be explored and interacted with by a person. It essentially allows the user to enter a virtual environment and interact with their surroundings. Predictive analytics is an advanced branch of analytics in which predictions are made about future unknown events. AVR is helping this area in manufacturing by being able to run simulations and detect flaws in design. This allows engineers to create better CAD models. By being able to interface with their design, engineers can run various tests on the concept and visualize how the product interacts with the intended environment. From this, flaws that would have not been apparent in the CAD model alone can be revealed. This helps save money and time and ensures that the final product is the best that it can be. Augmented reality is even more useful than VR when it comes to predictive analytics. AR adds graphics, sounds, haptic feedback, and smells to the natural world. This is currently being used by workers to have a heads-up display while working on an assembly. This allows them to have the part drawings, the tolerances, and the assembly directions in front of them while they are working. This has been shown to increase precision of the parts by 96% and productivity of the workers by 30%. Because of the higher accuracy in the simulations, AVR is useful in designing layouts for facilities. Unlike CAD models, VR models allow for time-dependent geometry and can model the workflow of the factory and allow the designers to better visualize and analyze the different design concepts. This allows them to choose the best design. Models of the workers can also be created to validate cycle times, part handling, and worker efficiency, while also ensuring that the workers operate in a safe environment. While AVR has made great contributions to the manufacturing process, there are still some improvements that need to be made. While 3D CAD models can be converted to a VR model, it is not currently possible to convert from VR back to a CAD file. Being able to do this would allow for faster editing on engineering designs. VR currently does not allow the user to feel interactive forces such as gravity and other inertial forces. This would be helpful in determining loads and stresses that systems and people would be under. Adding a type of sensory feedback due to the presence of these forces would be a useful addition. In the future, AVR will most likely be used in all types of design work, from creating the initial model to testing and editing the design. All assembly workers should be equipped with AR glasses to increase precision in production. This way, they can have all information needed for their jobs in front of them and be able to work more efficiently.
Big data is a developing term that can describe any extensive amount of structured, unstructured, and semi-structured data, which has the potential to be searched for information. It is used when a part of data becomes part of the current problem. There are 3 dimensions to big data: volume, velocity, and variety. Almost every industry uses big data, such as health care, retail, government, and financial services. Characteristics include there is too much data to manage for traditional tools, databases, software, and local servers to manage. Analytics generates a new knowledge of understanding and manufacturing. This can help reduce cost, increase production, and improve quality. Looking back in the past, manufacturing has always had big data. From historians to EMI and MES systems have been collecting data for decades. Every big data project starts with a practical use. Analyzing big data use in the manufacturing industry can reduce the amount of processing flaws, increase efficiency, and improve production quality, save time and money. However, there are lots of different data types. Hardly any of them are being used for analysis today. Providing parameters for the types of data that can be of value and help determine how to model data using Hadoop analysis. Hadoop is a tool designed to handle big data. It is a framework used for parallelizing the process. A company that manufactures PC microprocessors, Intel, uses big data to cut down on manufacturing costs. They were able to develop chips faster, warn about security threats, and identify manufacturing glitches. From using big data, the company considerably reduced the number of tests that are required for quality checking purposes. They saved over $3 million in manufacturing costs for a single line of chips by developing big data usage in manufacturing. Intel anticipates another $30 million. The future of big data uses less dependency on formal schemas and quality, more attention to raw data and extended metadata using pattern recognizing algorithms. Infrastructure on demand uses newer tools which are needed today, such as highly distributed parallel processes, cloud computing, NoSQL databases, and semantic web link data. Entering an era of Internet of Things, being able to gain insight from multiple data points, analyzing these insights in the current time period, and essentially using them to drive services. Coming to the future in the next 5 to 10 years, this can all be done cost efficiently.
Conclusions. The use of new technologies in manufacturing is only going to continue to grow as new technologies are created. Manufacturing times will decrease, part precision and accuracy will increase as a result of these new technologies. This will result in a higher quality of products that will be made for the consumers.